In this demonstration, I'm going to work through the first of the self-correcting exercises that go through how to calculate depreciation in an asset register. In this first exercise, we're going to be looking at applying straight line depreciation. So let's look at how we do that. You'll notice there's only 3 equations that we need to actually write and then fill them down. Let's go through the exercise. The first question to be answered is what the expired life of the asset is. You'll notice that the asset register is made up usually of some identification data. In this case, we haven't bothered to write in anything else. We're just putting in an asset number. Usually they have a unique asset number. They'll have a number of other details that might be particular to the type of asset and the way the organisation is holding them. But the key things you need to find is what the purchase date is, and we need to evaluate what the current replacement cost is. We're assuming that that's given to us in the asset register. We may need to enter these ourselves, or it's not uncommon, depending on what the purpose of valuation is, to estimate the current replacement cost in terms of escalating the historical purchase cost. This is particularly appropriate for some assets that are difficult to replace in their present form. But one way or another, we need to have the current replacement cost. We need to enter those into our asset register. The third thing we need to evaluate is the economic life. Again, this is often what the valuer will be called to do, usually with some kind of research into the asset type, maybe looking at the way the organisation uses its assets. Often in recent times, assets, especially plant and machinery assets, have actually been shortening their economic lives. So, for instance, in the area of scientific or technical instruments, say theodolites and total stations for surveyors, it wasn't that long ago that survey instruments were something that you could pass on to your grandchildren. Now they tend to be superseded in terms of the advances in technology, so a 10-year-old one is something that you might now use as a doorstop. So it's a matter of looking at what the genuine estimate of the economic life is. Let's look at how now to calculate the expired life. Now in this exercise I've put comments in so that they really take you through what's required, so you don't really need this demonstration. However, I'll walk you through what we're doing here. So if we read through the comments, we say the equations in Excel they compute dates in days, which means that if we simply take a difference between 2 date numbers, we'll end up with a number of days. And then we have to divide that by the number of days in a year, which we're going to take as 365. You can use 365.25. The only problem is that the self-correcting mechanism in this spreadsheet is set to a 365-day year, and so the yellow highlights won't go out if you use the more precise number of 365.25. That just means a little bit less typing for the exercise. But just keep in mind, depending on what you're doing and what precision you're working to, you may want to use the more precise number when you're doing these things in practice. Okay, the equation's fairly easy. We simply type in equals the difference in the 2 dates. We're going to open brackets, take today's date, the valuation date. We're going to F4 that. That gives us an absolute address. We're going to find that useful when we go to fill down a bit later. Now subtract from that the purchase date, the historical purchase date, close brackets, and now we're going to divide that. Remember, it's going to be coming out in terms of days. Now divide that by 365 days, and that gives us 22.75 years have expired since that asset was purchased. The remaining life is very easy. In fact, often we won't even bother about putting a column in for this. However, I'm doing it to make the final equation a little tiny bit simpler. And so that's simply equal to the full economic life minus the current expired life. That's a very nice, easy little equation. That's 12.25 years in this case. Then we get to the depreciated replacement cost. Now up here again we can look at the comment to get an idea of what I'm suggesting is the way to calculate this. and it's simply a matter of multiplying the current replacement cost by the proportion of the economic life that remains. Okay, what do we mean by the proportion of the economic life? Well, we've got the remaining life of 12.25 years. We've got 35 years as the full economic life, so the proportion there is 12.25 divided by 35. We're going to write that as an equation. So we're going to say equals the remaining life divided by the full life, so that's the proportion of the life remaining, times the current replacement cost. That gives us $70,000. They're the three equations. All we need to do now is fill those down and sum them, and the job's done. Very easy. Grab those, fill down, come down here. Now you'll notice that because we've got the protection on, which is basically my way of protecting the self-correcting mechanism, which is a lot of maths, which is kind of hidden away in different parts of the sheet where you can't find it. The protection being on means we can't use the auto sum. So normally you would use auto sum at this point. However, in this case, what we're going to do is simply write it in longhand. It's only half a dozen clicks or key presses, so it's not really a big deal. But if you're concerned about not being able to use auto sum, that's the reason why. When you build one of these equations or one of these models from the ground up, you will have the auto sum there, and that's really the lazy way of doing it, the way that I would do it, because I'm a very lazy bloke. And I like you guys to be precise and not do too much work. And there you have it. The depreciated replacement cost of that entire asset register is $4.498 million. Now, one other thing I'm just going to point out here is that very often when you're working with asset registers, you'll find that there will be hidden rows. You'll notice here we've got row 30, and then the next row you can see is row 111. Now, because the sheet is protected, you actually can't get in and see all those. But I will promise you, as an honest client, that those remaining 70 or 80 rows of assets are sort of in there, and they're part of my asset register, and you have to go and process those. Now, in practice, as a valuer, you want to be looking out for those because there might be mistakes in them. And by and large, depending on what numbers you have to put in there, you may have to go through and check them individually to make sure that the assets, the type of assets they are, allocate an economic life and that sort of thing. So be wary of the hidden rows. You'll notice that the hidden rows aren't affected when we come through and do our fill down. And so even though we don't see those hidden rows, they're actually included in the $4.5 million that we've got here. Obviously, if we sum the numbers that we've got there, we're going to end up a long way short of $4.5 million. Okay, so we're relying on the numbers inside those hidden rows. Should we see alarm bells when we see hidden rows? No, not at all. It's a very common strategy. And in fact, even working with spreadsheets is an advantage to hide the bulk of the asset register once you're happy with what the contents are. And the reason for that is that it makes the whole spreadsheet a lot easier to work with, because you can see the top of it, which is interesting and useful because it's got the headings in, and you can see the bottom of it where you tend to be doing your summations. And so hidden rows is very useful. You just have to be aware that they're there, especially with the plant and machinery work, where you'll likely be working with very long columns of numbers. Here we've hidden about, 80 rows just for convenience, but to give you a bit of a flavour for what's going on. In practice, it's not uncommon to be working with tens of thousands of rows on these spreadsheets. There are limits to what you can put into Excel. I've done one that sort of went to, I think, about a dozen sheets because we ran out of rows on a single Excel spreadsheet. But ultimately, the number of equations that went into that entire project, which was running into billions of dollars worth of assets, ended up being only about less than a dozen equations. And so if you know what you're doing, you can do extraordinarily powerful work in plant machinery with relatively small amount of input. Okay, that completes this one. The next one is going to be very similar. It's going to be working on diminishing value.